My name is Bill Collins. I'm a senior scientist at Berkeley Laboratory and a professor in residence with Cal in the Earth and Planetary Sciences Department. Two of the pieces of work that we've been doing lately concern abrupt climate change. This is a kind of climate change where the whole climate system changes over a very large scale, and it's hard for the climate system to go back to the way it was before. And two of the types of abrupt climate change we've been investigating are changes in the big land ice sheets, Greenland and Antarctica, and also in deposits of methane on the ocean floor known as clathrates. And the discoveries that we've made in those areas suggest that abrupt climate change, due to major changes in land ice and due to release of methane from clathrates, may be much more severe than previously thought. So climate change is caused, of course, by emissions from humankind. Probably the biggest crisis is that we continue to emit carbon dioxide at a very rapid clip. And measures to try to slow down the rate of carbon dioxide emission really have not taken hold internationally. Our best understanding is that the emission of carbon dioxide by humankind is the primary driver for climate change. And in some sense, the biggest crisis that we face is that internationally we have not started really coherent collective action by the whole of humanity to slow down those emissions. In terms of the effects of climate change, there are increasing signs that extreme climate change, this means short, rapid changes in the weather that are due to these emissions, are becoming more and more obvious as time goes on. So we've seen some very unusual weather patterns in the last few years. The reason why this is a crisis for humankind and also for the environment is that strange weather or extreme climate change is a real stressor for both humans and also for plants and animals. It sort of pushes the envelope for the kinds of weather that we're used to, and also that plants and animals are used to and are acclimatized to. So the more we see this strange weather, the more we'll be stressing both vulnerable human societies, but also vulnerable ecosystems that may be at the kind of the margins of their ability to adjust to rapid changes in their surrounding climate. In terms of solutions, a lot of the work that we're doing here at the laboratory and also at the University of California in Berkeley is devoted not only to understanding the origin of the problem, but also in looking at a variety of really innovative solutions for generating energy in a truly sustainable way. And so Berkeley Laboratory has created a program called Carbon Cycle 2.0, which is designed basically to move on to a new realization of the world's carbon cycle, but one in which it's sustainable long term, and by long term I mean centuries to millennia. Berkeley now has a coordinated program launched in the last couple of years devoted to understanding and developing new ways of producing energy and on the large scale in a truly sustainable fashion. So the solutions involve transitioning our energy systems away from carbon-containing fuels to carbon-neutral or carbon-free fuels. And I'm happy to say that both Berkeley Lab and University of California, Berkeley are at the forefront of research in those promising areas.
Cool. Could you maybe talk a little bit about your own research into and your personal contributions in your work here to kind of that project you had here at Berkeley Laboratory?
So I'm afraid most of my research is devoted to characterizing the problem, basically understanding what will happen if we continue on business as usual. So if we were to continue emitting carbon dioxide, what the climate would look like in the future. The work in my department and my group here is devoted to really understanding how the carbon cycle and how we're perturbing it, how those changes to the carbon cycle interact with the rest of the physical climate system. And in some sense we're sort of looking at a variety of forms of abrupt and extreme climate change that may come to pass this century if we don't alter our course of action. On the upside, the work that we're doing, we're building a new type of climate model in which the energy market and human beings are actually included as part of the model. And the idea now is to look at a coherent, integrated model to explore solutions. So with this new kind of model, we can project what would happen, for example, if we were to deploy carbon capture and sequestration on a large scale. How much environmental and climate change benefit would that have? If we were to deploy biofuels on a large scale, either cropped or more exotic types of biofuels, how much benefit would we see from that kind of deployment? So we're taking the climate model, which traditionally is sort of a crystal ball for all the bad things that could happen, and trying to turn it into a tool that will allow us to project the benefits from moving on to a more sustainable pathway. Looking at the combination of research in basic energy technology and also forecasting how those advances in energy technology will play out as we take them to market and begin to deploy them on a large scale. So again, building this crystal ball that allows us to look from the genesis of energy technologies in the laboratory to how they would play out in the market and at the state, local, national, international level, building that sort of that tool to really look out ahead and make sure that energies are deployed as best as possible. That'll be another major thrust for us going forward.